Have you ever stopped to think about why the world's most powerful AIs, the ones that can write code and poetry, can't just talk to a factory? I mean, it seems like it should be simple, right? Well, it turns out it's one of the biggest hurdles in tech today. But we're going to break down a new protocol that's a total game changer, acting as a universal bridge between the world of AI and the industrial factory floor.
All right, let's jump right in. First, we're going to unpack the root of the problem, what we're calling AI's Great Disconnect. Then we'll introduce the hero of our story, the universal connector known as MCP. We'll see how it builds that critical bridge to the factory floor, how it partners up with the existing industrial data highway, and finally, we'll see some incredible AI co-pilots in action.
So, let's set the stage. Why do we even need this bridge in the first place? Well, it all comes down to a massive chasm between two completely different universes.
Yeah, this is the multi-billion-dollar question, isn't it? We've got these amazing large language models that know, well, pretty much everything on the internet. But the moment you try to connect one to a factory, it's like it hits a brick wall. See, an AI speaks the language of text and code. A factory? It speaks in sensor readings, pressure values, and a whole mess of proprietary machine protocols. They're just not speaking the same language, not even close.
This right here breaks it down perfectly. Over on one side, you have the AI world. Think of this as information technology, or IT. It lives up in the cloud. It's all about general knowledge. Text, code, you get it. But then you have the industrial world. This is operational technology, or OT. This world lives right there on the factory floor, running on super specialized real-time data. For decades, this OT/IT divide has been this giant wall holding back innovation.
So how in the world do you build a bridge across a chasm like that? Well, that's where a new open-source standard comes into play, designed from the ground up to be a universal connector.
It's called the Model Context Protocol, or MCP for short. And at its heart, it's a standard, a shared rulebook that gives AI models a structured, predictable way to connect with external systems, tools, and, most importantly for us, that real-time data from the factory.
And honestly, this is the absolute best way to think about it. Imagine, before USB-C, you had a different charger for every single device. It was a mess. MPC is aiming to be the USB-C for AI. One standard port, one standard way to plug any AI into any system. No more custom-built, one-off connectors.
So how does it actually work its magic? Well, MCP is built on three really simple but powerful ideas. First, you have tools. These are actions the AI is allowed to perform, like querying a database. Then you have resources, which is read-only information the AI can look at for context, like live sensor data. And finally, you have prompts, basically templates to help shape the AI's answers into something useful. These three things give the AI a safe, structured playground to interact with the real world.
Okay, so now that we have the blueprint for our bridge, let's see what it looks like when we actually start building it right onto the factory floor.
Here's the key takeaway. MCP basically becomes a universal translator. It allows the high-level, abstract thinking of a powerful AI model to finally understand and interact with the nitty-gritty, complex language of industrial data. And the best part? The AI doesn't need to learn every single dialect of every machine out there. MCP handles the translation.
Now, this is where it gets really powerful. See, MCP isn't some disruptive tech that's trying to tear everything down and start over. No, its real strength is how it works with the standards that are already the backbone of modern industry.
You know, for decades, the industrial world has been perfecting its very own data superhighway. It's called OPC UA. It is the gold standard for structuring data and securely sending it from every machine, every sensor, every controller on the factory floor. It's robust, it's secure, it's the law of the land. But here's the catch. While OPC UA gives us this beautiful, perfectly structured highway of data, a general-purpose AI has no idea how to drive on it. It doesn't know the rules of the road. It basically lacks a driver's license to navigate this highway and make sense of all the information whizzing by.
And this analogy just nails it. If OPC UA is the data highway, then MCP is the GPS. It's the navigation system that can take a simple, human question like, hey, what's the pressure in tank 2? And translate it into the exact turn-by-turn directions needed to find that piece of data on the highway and bring it right back to the AI.
So you can see they're not competitors, they're the perfect partners. They're two pillars holding up the future of industrial AI. OPC UA gives you that secure, reliable pipeline of data from the machines, and MCP provides that intelligent layer on top,
the interface that lets the AI finally understand and act on all that data.
Okay, this all sounds great in theory, but what does it actually look like when the rubber meets the road? Let's check out how companies are already using this bridge to build some seriously powerful AI co-pilots for the factory.
A really cool early example comes from a company called Beckhoff Automation. They used MCSC to hook up a large language model directly to the controls for a robotic arm. And what this did was allow an operator to literally speak with the machine. They could use plain English commands, and the AI would translate them into the precise movements for the robot. Just incredible.
And this slide really brings it home. It shows how this tech transforms one of the most common jobs, maintenance. In the before world, an operator gets some cryptic error code like 3785 and has to waste a ton of time digging through dusty manuals. But in the afterworld, the AI co-pilot sees that same code, instantly translates it to coolant pump pressure is low, and even suggests checking a specific filter. This is an absolute game changer for cutting downtime.
And all of this is possible because there's a whole ecosystem of MCP tools popping up just for industry. You've got tools to connect directly to OPC UA data, tools to send notifications to Slack, tools to retrieve alarm histories, tools that can instantly search thousands of pages of technical manuals, even tools that integrate with middleware like Node-RED to manage really complex workflows.
This is such a great example of the power of making things simple. The operator doesn't need to know anything about PLC programming, they just need to state their goal in plain English. Turn the light on machine A to green. The AI figures out which MCP tool to use, that tool talks to a system like Node-RED, and that system handles all the complex, low-level commands to actually make the light turn green. It's just so simple and powerful.
So where does this all lead? Well, it brings us to a really fascinating and kind of provocative final thought. For years, we've thought about AI as a passive advisor, something that analyzes data and makes recommendations. But with a secure, standard bridge like MCP now in place, we are moving really, really fast towards a future where AI is an active participant, a true co-pilot, working side by side with humans on the factory floor. So the question isn't if an AI will operate machinery anymore, it's how are we going to work with them when they do.